Welcome to this afternoon session, DSC in a configuration management tool world. My name is Ben Gelens, in correct Dutch pronunciation. I'm a CDM MVP and I work at a Dutch consulting company called Inspark. You can probably find me online by my main handle as Gelens. I'm kind of everywhere. So so this session, why? Because I like to torture myself. I set a bar by introducing this, subjecting this session to this conference and saying, I'm going to talk about DSC in combination with those other toolings, which I don't know crap about, just so I have something to look forward to, right? So this has been my past couple of months investigating these third-party products in the Microsoft context. And I wrote a blog series just to, be better prepared, and now I'm going to deliver kind of the obvious things I took from that learnings. In scope for the session, I'm going to show you a nice little thing from Forrester, and from that moment on, it's just demos all the way until the end slide, okay? So why? I'm a noob, I already told you this, I'm just a noob, and I wanted to know. So, looking at the Forrester Wave report of Q4 of 2017, we can kind of see that, I did the box thing. So that Chef and Puppet in the configuration management tool world are kind of the leaders and the innovators, and DSC is here, somewhere in the middle part, right? Azure Automation is climbing a little bit up because it's going to be more of a configuration management solution, where DSC is, of course, more the platform. And the obvious wins of these kind of third-party toolings is, of course, they are solutions and not platforms. They do so much more. So, demo time. So I got a two-part demo. The first part of the demo is Chef. The second part of the demo is Puppet. I wanted to do Ansible, I wanted to do SaltStack. Turns out that 45 minutes is a really small time window. So I just stuck with those two. As you can see, I'm running Hyper-V locally on my machine. It's just 4 virtual machines. 2 that are dealing with Chef, 2 that are dealing with Puppet. Both have a server, both have a client. That's kind of their main architecture. And I'm already connected through PowerShell remoting to one of my Chef client machines. As you can see here, it's a Chef client, which already has Chef installed, because installing Chef client is next finish, and it takes a little while, and it's not that interesting. So I already took the liberty to do that before the session started. And Chef decided to put out a new version like last week or something. So I'm running on the version before that, just to make sure my demos would still work. So this is version 13.7. I believe 14 is out now with some optimizations in a couple of places. So looking through the Chef code base, I wanted to know, how does Chef integrate with PowerShell and with DSC? And I kind of found these Ruby gems, because Chef is written in Ruby and it makes use of gems, which are kind of like modules, or not really sure, but they look like modules. And we can see they have 3 gems that deal with PowerShell. So we have PowerShell script, basically runs PowerShell script. And we have the DSC resource, which we will look in a little bit. And we have the DSC script resource, which was kind of the first thing they did to interact with DSC in the WMF4 timeframe. So that's going to be the first part of our investigation here. So currently in this machine, my local configuration manager has never been touched. It's still in the default configuration. There's never been any configuration pushed to this VM, and so there is also no current configuration. I had to silence these out, or else they would throw. So, and in this first one, we're going to create a little small recipe. A recipe is kind of the configuration script for Chef. Containing all the resource declarations, just as if it was a DSC configuration script. So you can see we annotate that DSC resource, not the DSC resource, the Chef resource, DSC script, and we give it a name, and then we got our curly braces in the form of a do and an end, right? Those are our curly braces now. And inside of that, we have a code definition. And the code definition is just an attribute of this DSC script resource. And it contains a bunch of text, just strings. And you can see I have a marker here, and this is the end marker. And everything within that space is just interpreted as text. So what this resource actually does is it will take the code inside, and it will produce a configuration script out of it, will compile it into a MOF, and will send it over to the local configuration manager. So if I saved it to disk, let's do that. And I call Chef client in local mode, because Chef normally operates in conjunction with a server, but in this case we can give it a flag local mode. We can just read out that recipe and have it execute locally without a server to be present. So this means when you start using Chef, you don't have to start with the whole shebang. You can start really small, just install the client and start working with all the inbox stuff that's already in there. And luckily Chef ships all the DSC stuff inbox. So no need for additional installations. You can just go ahead and start tweaking with it. So as you can see now, this DSC script resource, which was compiled in the configuration script by the DSC script resource from Chef, got sent to the LCM, and it did a convergence, right? So you can see the output here that the DSC configuration was converged. These green lines means that actually an event occurred, something has changed. So if you look now at DSC configuration status, we can actually see that the Chef client did a push to the LCM. And we have all the artifacts in place, like that. So with get DSC configuration, we can also see the content of that configuration script resource. And we can test it, and we can see it executed with a test, and we can do a start existing. And this is also, straight from the get-go, the main problem I have with this resource and why you should never use it. You're instantiating a configuration outside of the scope of Chef, send it off to an LCM, and now you have two systems managing the same box, right? The one has its own timer, the other has its own timer, so you need to be careful with syncing them up, and well, they kind of have potential to drift apart. So how would we handle different credentials within that same resource? We would just specify, as normal, the PSDSC runners credentials, but we have this little helper annotation that informs Chef to convert these two strings into a piece credential object and put it in there. And of course, because we're compiling a MOF, we need to specify configuration data, that it's okay to have plain text password inside of that MOF, or else the compilation would fail and this run would fail as well. I'm not going to execute all of these because that takes a lot of time. So depends on, same thing, like we just have the depends on of the normal DSC resource there. And we can switch the dependencies by introducing that. So in this case, we had a who am I and a who are you. With the depends on commented out, that means that will be the way they are executed. And if we uncomment that, that would mean they got reversed, right? Because the first one depends on the second one. So that kind of changed the order. Dealing with external or custom resources, DSC resources, so first you need to install them. I just assume we have bad internet, so I'm just going to install that X networking module here. So this is a DSC resource module. And we can have that same DSC script resource, Chef resource, having it import that X networking module like this. And that would just convert this DSC resource.
Will it work with the module version stuff as well?
I'm not really sure what would be the extra metadata you would put in there, but I assume that works, yes. Yes. In this case, it will always work because there's just one, but anyways. So I'm going to clean up all the artifacts generated by this current implementation because I want to move on to the DSC resource, which is the resource you should actually use when you use Chef, in combination with DSC, of course. So let's clean it out a little bit. So when looking in that DSC resource gem, we can see on line 168 how it actually is using DSC under the covers. And I'm not sure if it's readable in the back, but the line there uses invoke DSC resource. So this is kind of the key on how those external toolings, just as Puppet will do as well, but Chef in this case, it uses invoke DSC resource under the covers to call in the test or in the set method of the underpinning DSC resource, right? So this kind of makes it really nifty, because you can put any resource underneath it and just have this one code struct dealing with all the custom resources. So a simple example in this case, again, we have the recipe we need to create. So this is a file, but in this case, we make use of the DSC resource. Again, we give it a name, and we have our curly braces in the form of do and end. We specify that we're going to make use of a resource of TypeScript. So this would be the PS desired state configuration embedded DSC resource inside of the PS desired state configuration module of version 1.1. So this is really explicit. And you give it all the properties. So the properties are defined with a colon in front. So with the script resource, we got get, test, and set, of course. And again, all the rest of the content in there is just a here doc or a string document. And we can define as well the PSDSC run as credential, again with a chef helper PS credential, which will convert these strings into a PS credential object. In this case, no need to define configuration data because we're invoking the DSC resource directly. There's no MOF compilation, so there's nothing whining about plain text passwords, because plain text passwords will never end up on disk, besides, of course, the recipe I'm persisting on disk. But anyways, that would normally not be the case, right? Because you would be dealing with a chef server. So, okay, I commented out for time's sake, because there's a really cool recipe later on that deals with everything. So I'm not going to apply this. Instead, I'm going to set things up by installing a custom DSC resource module, Docker DSC. And I'm going to show you that on this machine, there is the Windows containers features already installed, because installing a Windows container feature takes a while and it requires a reboot, and that's not interesting to watch in this demo. So, mental note for myself, first run, talk later, so I'm going to do that. I'm going to persist this recipe on disk and have it run. Bear with me. There we go. So, while it's running, I'm going to talk you through all the resources. So, what's cool when you use Chef, of course, you have all those Chef resources available to you already, and you make use of the DSC resource to extend into an area where Chef is not really there yet, or will never be, because this kind of makes that obsolete for Chef to produce specific Windows resources, because you could just hook into DSC, right? So you can see here we have this PowerShell package resource, which is a native Chef resource that deals with the PowerShell gallery. Whatever you define here would be a module that's on the PowerShell gallery and should be installed. So in this case, the PowerShell package, Docker DSC, I handled that here by copying it locally, just in case we had some bad internet, right? Then we have the DSC resource dealing with Windows feature. And it will install the containers feature. You can see the property here, name, containers, and should be present. And as soon as the resource triggers a change event, meaning that test resulted in a set to be run, it would also trigger the reboot action, reboot now. So if it's done, it would reboot before it would continue on with the rest of the resource declared. But because I already installed that feature, there's no need for the reboot now. What happens then is I use the archive resource, which is, again, a DSC resource, to extract the content of this zip file. So that's a C Windows temp docker.zip. It contains a Docker daemon and a Docker client executable. It puts it into the C program files directory. And because embedded in that zip is a Docker directory, it would output it into C program files Docker. Then we set up environment variable path with a path to that Docker path. And we make use of that custom resource from the Docker DSC module, calling into the Docker service resource, registering the Docker daemon service. Okay, this is kind of its purpose. And finally, we have a Windows service resource, which again is a native Chef resource, handling the Docker service to be started and be started automatically on reboot. So why I make use of a native Chef resource here, that will be a little bit later in the demo. But it kind of exposes additional functionality where we can have kind of a notification hookup. So that will be cool to see in a little bit. So I'm just updating my local environment variable here. So I have the latest path that was set on the system part. And I run docker info, and as you can see, this Docker daemon was perfectly installed. So now we want to update that configuration, because I don't want to have, in this case, it's just for demo purposes, but I don't want that name pipe of that Docker daemon to be the way to expose the Docker client to it. I want to make it available on a TCP port. And the way to do that is through a Docker configuration file. So I have this Docker configuration file defined here in this new recipe as a variable, right? So again, in the recipe, we can define as well variables. So C program data, docker config daemon.json is the place where the Docker daemon actually looks up when it starts, what it needs to set for its environment. So I have this file resource here that will set a host entry inside of this file. So it's a JSON file, so I have this host key, and I define that it should only listen on TCP. It can listen on every IP address that's exposed, but it listens on port 2375, which is kind of the default Docker unsecure port. So that's why I said on top here, never do this in production, right? So as soon as that file is created, what turns out is this, the file resource, the DSC resource, writes that file with UTF-8 with a bomb. And the bomb actually makes the Docker daemon explode, so we need to change the encoding to ASCII. And to do that, I notify, during this resource, that when it has a change event, it should actually run a PowerShell script, which is defined a little bit later, which is called change encoding, and it should run that immediately. So if we go a little bit down, we can see here this PowerShell script definition, which again is a native Chef resource. And it has this little code block in it that says, give me the content of everything that's inside this environment variable. And that environment variable was actually set with this attribute. So the environment here injects the environment variable of Docker config. And it just writes out that same file again, but using ASCII encoding. So the funny thing is that the DSC file resource never picks this up as a change. So I don't really know, but I think the file resource should be fixed. After that script has run, oh, and by the way, the default action of the script is nothing, right? So when there's no change event in updating the Docker configuration file, the script resource is never run. It's just there for handling a change event of another resource. But when it's done, I actually trigger a restart action on the Windows Service Chef resource, and it has to do that immediately. So this is a notification system back to this Windows Server Chef native resource that's capable of handling this notification. And it just has those actions exposed for other resources to consume, right? So in this case, it will be restart. Meaning that in one configuration run, I can actually do all my modifications in my file and have the service recycle itself, pick up the new changes, without me needing to provide you with an intermediate state. So if we do this in DSC, we would actually first need to create a MUF that stops the service, updates the configuration file of the Docker daemon, and then compile a new one, which is actually the desired state of the machine where the Docker service is started. Because with DSC, you cannot do this in one go. So this is high on my ask list for DSC to be implemented. So as soon as they open that Docker repo, I'll put in an issue, and all you guys should comment on that with thumbs up, right? So, did I already run it? I don't think so. No, let's run it real quick. And as soon as it's done, then my normal Docker info should fail, right? Because the name pipe would be gone. So we can see the Windows service was not changed because it was already started. Oh, it was really fast, good. Then we had the Daemon configuration. So the Docker configuration file was written to disk. And we can see here the DSC resource output. So that's really nice because this also ends up into the reporting end when you have a Chef server. So you can interrogate all the verbose outputs of all those DSC resources from the server endpoint. So this changed. And then we had a change in coding. So this was only triggered because we had a change event on the file resource. It changed the encoding. And then we can see that previous resource declaration for the Docker service triggered a restart. And finally, nothing happened again on the encoding. So with Chef, it runs from top to bottom, as with the configuration script in DSC, right? So it's a good information to know for a little bit later when we're dealing with Puppet. So right now, if I run this Docker info, it will fail. You can see that. So I update my environment variable Docker host, give it that TCP information, and now it runs again. So just to prove you there's no smoke and mirrors here. So what I want to do now is hook this Chef client that's still on its own up to a Chef server. And to do that, I have installed in my Windows subsystem for Linux the Chef DK, which is a utility belt that gives you the tools to interact with Chef server and do all kinds of other stuff. Mainly, it gives you the Chef command, which has a couple of subcommands. And what I wanted to do is combine those recipes I created, so creating the Docker host and changing the configuration of the Docker daemon into two different recipes and provide them as a cookbook. So I said here, Chef generate cookbook, and it takes a real long while to have that get going. But this would be the output of the command. It generates the cookbook, it scaffolds an entire folder structure and file structure, and finally you'll end up with something that looks like this. So this is the cookbook that's the end result of that. So in the recipes, you would end up with a default recipe. I did not change this one, I just included the recipes I created earlier in my demo. So this is the container host. So, and now with nice color scheme, right? This is a Ruby file. VS Code knows how to deal with Ruby files, but not so much with here strings. So we can see in nice colorful syntax what actually was the keys and what was the values. So this is one-to-one, exactly the same as what was in the first one. And the container TCP only was the second recipe. So those included, going back to that shell script, would be uploaded to the Chef server using a knife utility. Knife, Chef, I don't know, something cooking. So, and I pre-cooked this as well because uploading it to the Chef server would take a little while. So what you see here, and I don't know, it's really visible, but this is an implementation of the Chef server with the web administration portal. Not the latest and greatest, it's not Chef Automate, I'm not there yet. But when we look here in policy, we can see all the cookbooks. And as you can see, I put the psconfig cookbook already in there. And inside of that cookbook, we can see all those recipes that are in there. And we can see that same recipe definitions here, right? So it gives you a nice interface to see what's available to you and what you can do with it. So you could also interrogate the Chef server REST endpoint using knife and do a cookbook list. You would get the cookbooks out of that. And you can even go as far as, again, give me back the content of that recipe in a text format so I can read it, right? So you don't really need that portal experience, but it's good for demo purposes, I guess. So moving back to PowerShell and to that client machine, what I'm going to do now is onboard the client machine into that Chef server. And to do that, I need a key, an access key. So this access key is something that's used only once during the lifecycle of that Chef agent. So after it's being used, you can roll over the key, right? So if you make a photo of this, it doesn't really care. I will roll it over as soon as this demo is over. No, it's just kidding, but you would need access to my laptop anyway, so. So I need that key. It's in Chef validator PAM, and I'm going to write some instructions to disk. In the path C Chef, is a client RB file, and this just has the instructions for the Chef client to know, hey, where's my Chef server? What do I need? What do I use to onboard myself? And all kind of stuff like that. Also, like SSL verify mode. Normally, you would have a Chef server with a decent SSL certificate. Of course, I don't have a decent SSL certificate. I have a self-signed one. So yeah, I just tell it to not bother. Okay. So what we can do now is we can run Chef client, and we would provide it with an initial run list. So we'd say, okay, when you're able to onboard yourself into that Chef server, what you need to do is get the recipe from this cookbook. It's called psconfig, and the recipe you need to get from it is container host, and that would be the recipe assigned to this node initially. So when I run this, actually the node object is created on the Chef server side, and this little piece of data would be persisted there straight away, and the Chef server would know what recipe to relay to this node. So we can see now that we are onboarding, and we actually are already running that recipe. So this node is now newly introduced through the Chef server, and it has its configuration assigned. So as you can see, everything is already in a correct state, so no change events, everything's fine. So that's not fun. Let's introduce some change events, right? So, okay, mental note for myself, go to portal and adjust. Okay, good, I put that in there. So, we have our new node. So this is a new node. It's last check-in a few seconds ago, as you saw. And as you can see here, we have the run list we initially provided. And I can edit that run list. And as you can see now, it just has one recipe assigned, but I can easily expand the composition of recipes by just picking this up, dropping it in, saving it up, and from now on, that node will pull the other recipe as well and execute that as well. We can even go further by defining roles, which are composed of run list again, but we have like a higher level object where we could have multiple roles, for example, a base server role, web server role, an audit role, merge them all together inside of this run list, and maybe those will be like 20 or 25 recipes, but it will be a nice, clean site, right? So composition with Chef is really easy. So now for the change events, we're going to stop that Docker service, remove that daemon configuration, and let's run the Chef client. So I did a server-side change, and if everything went correctly, the Chef client will pick that up and will now actually execute both recipes in order. So here comes the first one, and by the way, you could already see it here. You could see the run list has been resolved to container host and container TCP only, so both would be run one after another. And we can see some changes happening here, right? So the encoding was again triggered because that daemon JSON was gone, and we're done. So as you can see, we are finished, and we have 4 change events in 11 resources. So that's good information to know. So if we look at that daemon configuration, it's there again. Docker info still works. And when we head back to the portal and we go to reports, we can actually investigate that run history from that agent pretty well. We can see from the first side which resources were not in the desired state, which were drifted, and we could see that, okay, the Docker service that was not started, it was stopped, and of course there was the change event I put in. That daemon configuration was not there, and it was, oh, by the way, it was created using these parameters. Oh, and this one doesn't have any parameters. This one had parameters. So we have rich reporting experience from the portal, and if we go through the REST API, it's even better. You can get more information through the REST API. So I hope you're all seeing the value add of Chef, what Chef brings if you're used to only using DSC. We can see some notification stuff, some composition, and actually Puppet does kind of the same thing. So with that, it's a good kickoff for the next demo, right? If there's no questions, by the way. Questions? Good. Good. So same thing applies here. 2 servers. We have a Puppet server. We have a Puppet client. We have Puppet already installed, as you can see here. Again, was next finished, not really interesting, just an executable. It also has a version, just for record, so you can see, version 535. And Puppet also ships out of the box with something it's called types. And enumerating those types will take some time. And because we're enumerating types a little bit later, I will skip that for a little bit. But I can tell you this, that out of the box, Puppet does not deal with DSC. You need to extend Puppet with additional modules to expose DSC resources to it. So how can we do that? We reach out to something that's called Puppet Forge. Puppet Forge, like the PowerShell gallery, and by the way, Chef has the same thing called Supermarket, I believe, or Super Cookbook Market, something. Yes, Supermarket. So in this case, it's Puppet Forge, and it's a repository of modules. And you can see we got from the Puppet Labs, which is the official Puppet. You know, the puppet guys, the official puppet guys. And what? The puppeteers. Yes, the puppeteers. So, thank you. So, and they kind of released 2 modules. The first one has been around for a long while, is the Puppet Labs DSC. And we, just a couple of months ago, I believe, we were introduced to something called DSC Lite, which I prefer. But first we're going to look at the Puppet DSC module. I already installed that one because it's a couple of megabytes big. It takes a little while to download. And my encoding is a little bit screwed here, but these would be like lines. Puppet Lab DSC already installed version 150. So if we look at those types I mentioned earlier, we can enumerate all the types available for this Puppet client. And we will look for types that are prefixed with the name DSC, and we will select the first 10 because how many resources are there in the DSC resource kit? Well, that's how many types it will produce, 1-to-1. It's just a 1-to-1. And those are many, right? So I believe Puppet has this saying, we like to ship with batteries included. And that means that when you use one of their modules, there's really no external dependencies anymore. You bring in the module, that should be it. And that also is the case with this DSC module. It will bring in all the DSC resources from the DSC resource kit with it. So those batteries are included in that sense. So you can see here the first 10 in the grouping, and we can see the DSC file, DSC group, disk, and so on. When we look at this location, where the DSC module is located, there is this lib directory with the types, and those are Ruby files. And we can see Ruby representations of those resources, right? So this is how Puppet knows how to do the translation to calling into the DSC resource itself. So one of those is the X time zone resource. So if we have a little look in there, we can see actually that it contains a PSD1. I don't think Puppet uses PSD1. X time zone PSM1. So as you can see, it's really the DSC resource that's included inside of this module. So how to make use of that? My current time zone is Pacific Standard Time because I next finished my Windows installation. And I have this Puppet program. So this is just as with Chef, is a text file you persist somewhere. In this case, I have the extension PP, and that's that's the Puppet program, right? And when I think about PP, it's something else. But that's because you have kids. Right? I have kids. Yes, thank you, Dortek. Thank you for saving me. Yeah. So we have Puppet with the subcommand apply. And we target that to the Puppet program, so the PP file. And it will actually do the similar thing as DSC does. It will take that Puppet program, look at it, and it first will convert it into a different format, a catalog file. So it does compilation, so to say, and the catalog file itself will be handed over and contains the actual desired state. So you can have like a similar observation here as to a MOF file. So the catalog file would be the MOF file. There's no real runtime evaluation here, as with Chef, actually what was executed executed was the recipe on the machine itself. So you could have more runtime specifics embedded with Chef by looking at the environment variable while the Chef client was running. With the Puppet, I believe it's a little bit more difficult to do the similar thing. And I don't know if that would be something you want to do in the first place. But let's see if we changed. Yes, we changed. So this really simple Puppet program using that DSC resource under the cover actually works. So how was this triggered? Somebody can ask. Somebody can guess how this was triggered under the covers? Yes, invoke DSC resource. So we have direct resource access. So invoke DSC resource was used, right? So this will be the evidence of that. If we look at get DSC resource, we can see we only have the resources that ship in box. So no additional resources were actually installed by Puppet. So how did Puppet do this? Well, if we look at line 59 of this provider, we can see the invoke DSC resource provider. We can see that if you read this, it kind of injected its own path into the module path during the run. So this is how it introduces its own DSC resource kit modules, and it prepends in the piece module path, so it would always be first, so it would not conflict with anything that you have in box, right? So batteries included also means that it's validated and tested and it should work, and it also means that if you did something strange on your own machine, it should not conflict with what Puppet is doing. So I think that's good. But for now, I'm going to remove that module because I like to play with a lot of custom resource modules and not so many that come from the DSC resource kit per se. So I like to define the resources I want to use myself. And if I want to introduce my resources to that main DSC module, the Puppet module, I would actually need to go out to GitHub, clone it, do a kind of build process, and it's decently documented, so you would be able to do it. But you had to do it every DSC resource kit release again, right? You need to include your resources again and again and again. And that kind of is not the way I want to work with it. So I already downloaded that DSC Lite module. And when we look now, I just installed it because everything is nicely copy installable. It's all really contained. You can see we now have that DSC Lite module. And as you can see, version 0.20, meaning they don't support it. Okay? So when we would look now with the Puppet resource types, there would be only one, and that would be the type DSC. Just as with Chef, where we have the DSC resource, with Puppet we would have the DSC resource. I think Puppet did a better job there by not appending the resource thingy. So making use of that in the Puppet program, we have that resource definition, DSC, and we give that a name. And then we have our stuff underneath. So we have the DSC resource name. We're going to make use of the script resource that comes from the module PS Configuration, version 1.1. And also here you can see we are making use of fat commas. That's just something Puppet do. This is actually an equal sign with a greater, smaller, greater than. Yes, thank you. So just defining that everything after should be the input. Here you can see the DSC resource properties that are defined in its own code block. We can see get script, set script. And please make sure these are lowercase always. No matter how they are originally, they should be lowercase for Puppet or else stuff breaks. PSDC runouts credentials also defined here in lowercase. And as with Chef, also Puppet brings in these helpers. So we have this helper type, MSFT credential, which ensures that user and password will be converted under the covers to PSDC or to a PS credential object. So writing that to disk. And checking if I have that file, and the reason for that file will be apparent in a bit. Doing the Puppet apply, so again, that Puppet program is compiled into a Puppet catalog. That's the first thing it does, so it will be evaluated. And by the way, Puppet doesn't process top to bottom. Puppet processes how it thinks it's best. So if it thinks the last resource is best to process first, that's fine for Puppet. Okay, it can do that. So this is something in the DSC context you need to think about, and we will look a little bit how to deal with that later. So right now you can see it's done, and we can see we have this ensure created. So we had a change event, and if we look at that text file, we can see that the run of the resource invocation was done as Puppet client administrator because we used the PSDC run as credentials. No further verbose information was provided to me, so I did not see the verbose output streams of that resource. So this could be something the DSC Lite module, Puppet module, could expand upon a bit. We could set it in debug mode and have more verbose output, but actually what that would output was the invoke DSC resource ERB file, and the ERB file stands for embedded Ruby block. And it basically just generates the PowerShell code that's executed to handle the invoke DSC resource, but it would not produce the output for us, so it's not really helpful. So get DSC configuration status. We can see again direct resource access, so invoke DSC resource under the covers. And how could we investigate still, because we're PowerShell guys, right? We know where to find those files. We can actually go into the configuration status repository that's persisted on disk here, and we can look for the last one that's been written down, and we could see the verbose information if I'm able to scroll to the right somewhere. No, I'm not able to scroll. Anyways, it's not really important, but you could still investigate that file, right? And just to show you, there's no current, there's no pending, there's no backup.mov, just to make really sure that this is invoke DSC resource under the covers. So we're going to do actually the same thing as we did with the chef. We're going to make this a Docker host. Again, I'm going to copy in that Docker DSC, DSC custom resource module. And again, a mental note, run first, explain later. So let's just keep to my own advice. Time is precious, right? Too many resources. Like that. So I created that Puppet program. As you can see, there's currently no Docker service. Let's apply that Puppet program and let's go through those resources. So this Puppet program contains a DSC resource definition for the script resource, installing the Docker DSC module in case it does not exist. Because Puppet does not have its own gallery resource, so we need to be a little bit creative here. So I handle that with just a script resource, DSC script resource. Let's see, we have the DSC definition handling the DSC resource for Windows feature coming from the PS desired state configuration module. It ensures that container feature is present. Then we have a Puppet native resource. It's called reboot. Guess what that does? So if a reboot is pending, it would introduce a reboot, right? We again had that zip file prepared in the temp directory. It uses the archive resource to extract it into program files. We have the system path environment variable appending the Docker path to it. We have the call to that custom resource, Docker service, coming from the Docker DSC module, ensuring the daemon is present. And this requires some of the other resources to already be in the desired state. So this is the way to handle with Puppet the dependency tree. So if you don't trust Puppet to make the correct decision, you can define it like this. So we require the container feature to be present, we require those daemon files to be present, and some other stuff. So then we have a native Puppet resource, the service resource, similar as to with Chef. We make use of the native resources where they make sense, right? I think you should always see if they have a native resource, because probably they have a lot more functionality as the DSC resource equivalents. Especially in the language definition, because these kind of guys have those require statements and notifications, the stuff that we need in DSC, right? So service resource ensure should be running, enable is true. So in the Linux world, enable is kind of the equivalent of automatic, right? So this is just a loosely translation there. It requires that service was actually registered. We have that directory structure that needs to be in place. The C program data Docker config directory structure, and then we post in a file using the native Puppet file resource in this case, because it produces correct encoding, saves me from re-encoding it. And this one, again, when it has a change event, it will go out back on top to the service resource and trigger a restart of the service. So this is a good example of not having to deal with intermediate state with DSC by utilizing a third-party's CM solution. Kind of overhead, but anyways, I think these are nice value adds there. So if we now look at if that service is there, it's there. And we actually, when we update the path environment variables, we can see over TCP we connected to that Docker daemon. So clean up a little bit. And how much time do I have left? 15 minutes? Okay, cool. So I'm going to clean out the Docker daemon, remove all kind of files, remove all kind of modules, and set it up to be onboarded with Puppet server. And the reason I clean it all up is because you don't need all that stuff installed on your Puppet node in front to make use of all those extensibility modules. So let's connect to that Puppet server. And I'm making use of Puppet Enterprise because it's just it works straight away. There's no need to fiddle with installing all kind of web services and making your own kind of open source Puppet work. This just is an install next finish, so to say. Well, actually it is, because when you install it, it asks you to go to a web page to do the next finish. So this just works, and it's free, I believe, for 10 or 15 nodes, so you can play with it all you want. The Chef server, by the way, is also free until 5 nodes, I believe. So if you want to play with it, don't be scared of it with licensing requirements. It has this little configuration inside. It's set auto-sign to true. Normally what you do when you onboard a Puppet node to its master, it does a certificate signing request. So it sends in its certificate signing request, and some admin need to go in and say, okay, this node is allowed to be onboarded into this server, sign it, and from that moment on, that Puppet node is part of the Puppet infrastructure. But I did this dirty workaround. I say auto-sign, meaning that no admin should be bothered, just do it, it's fine. So it's not really for production, but it works really well in demos. So Puppet module list, we can see we have a default directory. It was used to instantiate that Puppet master. And we have this environment modules directory. So environments productions modules containing no modules currently. So my Puppet node would actually by default go into the production environment when it's onboarded. So this would be the place for those Puppet modules to be staged, right? So we can install those, and I presume bad internet, so I do a copy install, but you could do direct installation from the Puppet Forge if you wanted to. So if we look again, real quick, we can see now that the production environment has these 2 Puppet modules available. So we can now generate a custom module calling DSC psconfig, but it needs to be prefixed with these initials just to satisfy the Puppet module generate command. After, we will delete the prefix because it's not accepted to use. So I'm not sure why that's there, but we have this module directory now. So this is the scaffolding that's been done. We can see we have the root directory, we have manifest, and we have that initial pp file, so the Puppet program file. The pp file would contain the Puppet program we want to have embedded there, and we can do all kind of other things, just as with the Chef Cookbook with that. But for now, it's just to handle our Puppet program. So I defined this Puppet class here, class DSC psconfig, and you can view this as if it was a configuration script from DSC. This is just something so we can refer to it when calling it. So we can see it doesn't take any parameters, it just has a resource definitions. And those are actually one-to-one the same definitions we just ran. So nothing special there anymore for you. Let's just persist that to that pp file, hopefully. And then let's edit that manifest file by getting rid of that prefix. Sorry for the VI guys, but you need to know this. And we actually don't have any external dependencies, so we get rid of those. So we've now updated this, this Puppet module, and I'm going to install it inside of the production environment. So normally this, of course, the entire production environment would be in source control, and you would handle it through source control. But yeah, this is good for demo purposes, right? So if we do another list, we now can see the DSC psconfig module being installed. And to assign it to a node, what we do is we go into the production environment, into the site pp file, which is a special pp file, and we add a node declaration there. There's other possibilities. Please go to my blog post, because I did a dynamic assignment post where you could assign a configuration based upon facts delivered by the node itself. So there's kind of ways to play with it. But for now, just be really explicit. Say if the node has this name, it should have this class assigned. Okay? And if we look at that file, we can see that's the only node definition inside of that site pp. And with that, I'm going to onboard it, because I'm running out of time. So also the node has this puppet.configuration file, and by default it will look for a Puppet server, or Puppet as the server name. My server name is a little bit different, so I'm going to replace that with its fqdn, just so I can contact it. And I do a Puppet agent test, and the test will actually invoke that it sends out the certificate signing request. And because I have the auto sign set up on the server side, actually the signing request is handled immediately, or else this would wait for a certain bit until an administrator would go in and say, okay, it's fine. As you can see, stuff is working because the screen is scrolling. It does a lot of facts gathering, but actually the catalog file is compiled on the server side. So not on the client side. What the client does, it will gather its facts. It will send it up to the server. The server will take those facts, put them together with the Puppet program, and handle, well, there's a potential there for configuration data handling through that facts. Define the catalog file and send that back to the Puppet node. So it's doing its thing, and it's applied. So it says shows a rep report. So let's do that real quick. So this is a Puppet enterprise portal. So if you deal with the Puppet open source, you don't get this portal. That's one of the biggest reasons to use Puppet Enterprise, because you got this nifty portal. So as you can see, we have 2 nodes now. Let's zoom in a little bit. And we can see here this Puppet client, and well, all kind of information that's sent back by the Puppet node to the server. So this was the information I was talking about. You can actually extend those facts with additional information, get it from whatever you want, because it can be programmatically set up. So you can see, for example, the Hyper-V is not running on this machine, all the IP addresses, etc., etc. So a lot of information to work with. And we can see the reports here. So we had 90 change events, or 90 changed and 89 unchanged. Not really sure why it says that, but at least we got some good reporting information. So all the verbose and debugging statements, they got sent up. And when we look at the events, we can see of type DSC resource, all those resources were either unchanged or intentionally changed, meaning that we had configuration drift. So from the reporting side of things, you don't have to parse all the embedded JSON data to figure out which resource was actually drifted that well, made a change event to occur again, right? So if you have a node in a lifecycle management, and you're curious why a certain resource was drifted, this would make it a little bit more apparent, as the DSC native reporting would provide you with. So there's a whole bunch of stuff. I wanted to give some additional reporting there, but since we're running a little bit out of time, just going to show you the cache. So the Puppet node downloads the cache, and inside of the cache there are all the things it needs to converge into the desired state, including all the Puppet modules and stuff like that. So this is where it stages the data, and this is why you don't have to install the stuff up front. The catalog file itself is actually a JSON file, so it's a little bit easier to work with as a MOV file. And we can see from this catalog file the version of it and which resources were used in it, which classes were assigned. So if we dig a little bit deeper inside of the resources, we can actually see all our DSC resources being explained and having their associated files which get triggered to handle change events. And in this case, this is one that deals with the DSC script resource, and you can see all the settings that were in there, right? So you can investigate that catalog file a bit. So with that, it's kind of the end of the demo. So obvious. Both Chef and Puppet, they consume DSC resource through invoke DSC resource, if you're doing it correctly. Chef has inbox support, Puppet does not, but it's easily installable. It's just a really small, relatively small module if you use the DSC Lite one. The other one is a little bit more complicated, but it's supported. So it's kind of what is your game. Obvious wins of both. Notifications, I think you all can agree that notifications is a good thing. It keeps you from needing to handle intermediate state. The configuration composition is really nice because also on the Puppet side you could just have multiple classes defined inside of the node declaration. Reporting is a bit more mature as we are used to with DSC. And the ecosystem and the communities are really rich because these tools have been out there for a long time, have major adoption, especially in the Linux world, and we can learn a thing or two from these guys. So, I have this book to give away, but I need some good questions to define who to give it to. I have two. So, let's see if we have some questions. Yes?
Any issues using complex DSC resources in either of the two?
Yeah, so the question is, did you have any issues using complex resources using any of the two? So, sorry? I don't like SharePoint at all, so I'm not touching that one. So that's another guy. You need to find the other guy. So no, actually, what is the thing is because everything is Ruby DSL, and you can play with the Ruby there a little bit. Is that you need to figure out how to translate how you would define it in PowerShell to how you can define the same thing in Ruby. So if you're not schooled into the Ruby part of it, that could be kind of an obstacle. But it's recently well documented. Both of these platforms have solid documentation. So it's relatively easy to figure out if you just think a little bit out of the box. So you think SharePoint, I think, for example, Hyper-V or containers or whatever. It's going to be a more useful search. But yeah, so what I will do is I will put your name down. So what's your name?
Brian Douglas.
Brian?
Brian?
Yeah? Douglas. So if I get more questions, I can do a nice get random, right?
Okay, about the partial configurations and intersections. For example, I have a few partial configurations, and in A and C, I have similar resources being configured. How does Chef and Puppet handle that?
Okay, so the question basically is partial configurations, how would that apply to Chef and Puppet, right? Basically, it does not apply because you're doing your stuff in code entirely, and you kind of work out of your source control. So if you have a multi-role implementation, with Chef you could see I could just drag in additional recipes or drag in additional roles, and it will be the job of the guy coding up those recipes to make sure that there's no inconsistency there. And I think the same thing applies for the Puppet end.
So, for example, I have a team for Windows OS, I have a security team, I have a dev team.
Yeah.
They all need to work together, writing the recipes or typing.
Well, yeah, they should be friends. Yes, yes. But they They could work out of the same source control, of course, and do PRs on their own stuff. And you could merge stuff up, I think. I'm not really an expert yet, because I'm the noob, right? So I'm going to put down your name. Matthew? Like that? Okay. We got more questions?
I was just curious, having looked at these different management tools, what's your personal preference at this point?
So the question is, looking at
Any direction?
looking at these tools, what would be my personal preference? And this is the last question, because I'm sorry we're out of time. I look more like being a chef person first. Then I'll really like the Puppet stuff. And I don't know. it's really tough. They both have their advantages. They're really nice tools to work with. I think what would be best is to figure out if one of these tools already runs in your environment. Go and talk to those guys and go with them, because there's so much knowledge to be gained before you can make use of these tools in a good coverage. And it requires basically a bit of knowledge before you can make good use of them. That's something I got from it. So, your name? Christian. So we got 3. So 2 out of 3. So this will be, let's do it on the Puppet client, that's fine. So Matthew and Christian, you get the books. So make sure you come to me. I'll send over your emails to Ravi, because Ravi is the author. The ebook is out now. The ebook is out now as ebook and will be a paperback in May-ish, right? That's right. So, slides. Thank you.